This will be lesson 2 on page 147 of your student workbook, and it's going to be the first video of 2. So I'll do this lesson in 2 separate parts. As with lesson 1, a lot of information, so I want you to be watching Mr. Prama's videos as well on YouTube, and he has 2 videos out of his 24, which would correspond to this lesson. Okay, so the first thing we're going to look at is we're going to revisit something from junior high, which is Pythagoras Theorem. So Pythagoras Theorem, remember, is based off of a 90-degree triangle. So whenever we have a 90-degree triangle, the hypotenuse of that triangle will denote as C, and then the other 2 arms of the triangle I'll call A and B. So Pythagoras Theorem, if you were getting if I said, well, calculate what the distance of this hypotenuse is, the formula for Pythagoras theorem would be c squared is equal to a squared plus b squared. Okay? And using that formula, you'd be able to calculate the distance of this hypotenuse. Now, what's going to happen in trig is we are going to be dealing with triangles on the Cartesian plane, right? So on a Cartesian plane, you're going to, from the vertex or from the origin, you're going to have a terminal arm. And remember that I said every single terminal arm could make an acute triangle. So you would draw a vertical line from a point on your terminal arm to your x-axis. So maybe I should label my axes, x and y. And from here, we have a triangle. Now, instead of this side being length A, we are now going to call that length x, right? So this will be length x. And this distance here, so the length of that arm there, instead of calling it b, it will now be y, right? And this, you guys, instead of calling it c, we are going to call this the radius. And the reason is because you could take a terminal arm, which I have, and this terminal arm, you could spin it around and do a complete rotation, and you're going to get a circle, right? So here's 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I should actually add, we start at 0 degrees. So you're going to, and on your circle, this distance would be my radius, right? The radius is halfway around a circle. So now, if I said, well, calculate what r is, instead of c squared equals a squared plus b squared, we are now going to use r squared is equal to x squared plus y squared. Okay, so we're just taking the idea of Pythagoras theorem and we're going to be changing the letters. C is now always going to be your radius. So what's a class, like what would this look like? Let's do a question. So class example 1, sketch the rotation angle in standard position, and they want point P to be 5, 12. Sorry, negative 5, 12. So I know that that's my x coordinate and that's my y coordinate. Let's label our axes. There's my x-axis and here's my y-axis. X, they want to be negative 5. So I'm going to say that that's negative 5. And they want y to be 12. And they want this point here. Okay? So that point is at negative 5, 12. What you always do is you draw yourself a terminal arm going through that point. So just like the last lesson, draw yourself a terminal arm from the origin going through that point. Okay, so all these points are going to be on terminal arms. Then we do the same thing that we did in the last lesson. Make yourself an acute triangle. So from whatever point on your terminal arm that they give, draw a vertical line to the x-axis. Okay, here's my triangle. Now I want you to label what sides on your triangle you can, because we have 3 different sides on the triangle. So I'm going to erase this -5. And I know that the on my triangle, so this is at -5, which I'll keep. My y, actually what I'm going to do is I'm going to move that. So this distance from here, from the origin to here is -5. But if I said, well, what would that distance on the triangle be? We can't have negative distance. So I would just say that that's 5, right? That's 5 units. From 0 to -5 is 5 units. And what would this distance here be? That distance is 12. Okay. What I don't know is r. That's what we're going to be calculating. And then what this question is saying is calculate the exact distance from the origin. So here's the origin at 0, 0 to the given point. So they want to know what my radius is. So let's write that down. R squared is equal to x squared plus y squared. R squared is equal to, my x on the triangle was 5. And my y on the triangle was 12. 25 plus 144. R squared is equal to, if you add up those two numbers, you get 169. Sorry, r squared is 169. And then I would say, okay, well, what's the radius? How do you isolate r? So to get rid of a square, you would square root. And r is equal to. Now this is interesting because when we did the unit on radicals, you knew that if you square both sides of an equation, that our solution is plus or minus 13. However, one of these numbers doesn't make sense. And you have to say to yourself, can you ever have a negative distance for radius? And the answer is no. Just like this -5, I said, well, that length of that side is actually 5. So when we're doing what the radius is, you don't actually have to say plus or minus 13. The radius of this is 13. Okay, because radius is always going to be a positive distance. Let's do class example B. So find this point. So I want everybody to pause this video and see if you could plot x comma y. Draw yourself a terminal arm going through that point and draw yourself a triangle. Label your triangle. So pause the video, do that. Okay, x is -2. Y is -6. That point would be right here. Point Q is at -2, -6. We always draw our terminal arm going through that point. From your terminal arm and that point, draw your triangle. Your triangle goes up. It's a vertical line to your x-axis from that point. Here's my triangle here. If I said label the sides of your triangle, or if you were in class and I said, okay, well, what's this distance here? You couldn't say that that distance is -2, right? That distance is 2 units. So I'm going to put a 2 here. And then this distance, my y, it's not -6, it's 6. And I don't know what my radius is. So r squared is equal to x squared plus y squared. R squared is equal to x is 2 squared, y is 6 squared, 4 plus 36. R squared is equal to 40. We square both sides. R is going to be equal to the square root of 40. Okay. Then we have to reduce this, so we have to think back to our radicals unit. So 40 divided by 2 is 20, 20 divided by 2 is 10, 10 divided by 2 is 5. So the square root of 40, what that would reduce to is 2 root 10. Okay, we could check that on our calculator if we need. So square root of 40 is equivalent to 2 root 10. Exact same irrational number, so we're correct. And that is equal to my radius. Okay, flip the page. We're going to do class example 2 and 3, and then that will be the end of the first video. I'll give you some homework to practice, and then you'll watch part 2. Okay, everybody remembers 10C, and one of the things that students loved in 10C was Sohcahtoa. In 20-1 and 30-1, I'm going to show you in this example here, Sohcahtoa, and then I hope to never talk about it again. Because in 20-1 and in 30-1, we do not deal with Sohcahtoa. But let me review this so that you could refresh the ratio. So there was 3 ratios, and I'm going to talk about Sohcahtoa in this example, and then I'm going to be done with Sohcahtoa, okay? So the sine ratio. There's 3 ratios in trig: the sine ratio, the cos ratio, and the tan ratio. And a ratio is a fraction. And the sine ratio is the fraction of the opposite side over the hypotenuse. So if you were given an angle, that would be our given angle. Give that angle a set of eyeballs. And remember that that angle always stares at the opposite side. The hypotenuse, sorry, the 90-degree angle always stares at the hypotenuse. And by default, after you've labeled your opposite first, hypotenuse second, the third side by default is always your adjacent. So the sine ratio, if I said what's the sine of this angle, sine is opposite over hypotenuse, and that it'd be exactly that. The sine ratio is O over H. The cos ratio of this angle, cos is A over H. And the tan ratio, tan is TOA, which is the opposite side over the adjacent side. So those are the 3 primary trig ratios, what we call. Though what's going to happen, like I said, in 20-1, I'm not going to be doing Sohcahtoa anymore, and in 30-1, we're not going to do Sohcahtoa anymore. Okay, so why do I not do Sohcahtoa? All triangles that we draw now fit, we could always, and any triangle that I draw, I could now draw in quadrant 1 on my Cartesian plane. And I know from class example 1 that there's 3 sides to my triangle. This distance here is x, this distance is y, and this would be r. Now, you know that sine from this example here of your given angle, so my given angle is this guy right here, sine is opposite over hypotenuse. But I don't want to use the letters O and H anymore, right? So if sine is opposite over hypotenuse, there's my opposite, which is y, and my hypotenuse is r. So the sine ratio that we're going to use in 20-1 and 30-1 will not be O over H anymore. The sine ratio is going to be Y over R. Now, how could you memorize, like the acronym Sohcahtoa everybody liked because they could memorize it. How could you memorize that sine will always, you guys, 100% of the time be Y over R? So what you're going to memorize, the acronym for sine that you're going to just remember is 7 for sine, Y will be yellow, and R is going to be rabbits. So if you can remember 7 yellow rabbits, that is what the sine ratio is. Sine of theta is y over r. Okay? Now, cos of theta. So I always tell my students, you just remember the 7 yellow rabbits, and then you'll always have sine. Cos of theta is, cos was a over h, right? Adjacent over hypotenuse. So in this triangle here, the adjacent side is x. And the hypotenuse is r. So a over r would be x over r. Now, I always say, okay, if you guys remember that sine is 7 yellow rabbits, so sine is y over r, cos is always going to be x over r. So just remember that y goes with sine, x goes with cos, okay? Tan is toa, which is opposite over adjacent. So according to this, the opposite side is y, and the adjacent side is x. So my new trig ratio for tan is y over x. Okay, so when we do examples from now on, I'm not going to say sine is O over h. I'm going to say sine is 7 yellow rabbits, which is y over r. Cos is x over r, and tan is y over x. Some students use the phrase 7 yellow rabbits to remember this. If you can remember sine is y, then cos of theta is x over r, and tan of theta is y over x. The point 15,8 lies on the terminal arm of an angle shown. So that's my x value and that's my y value. I'm going to put that as point P, and they want that to be 15,8. So once you have that point done, label your two sides of the triangle. One of your sides gets 15 and one of your sides gets 8, right? So this is x. So x is 15 and y is 8. I don't know what my radius is. So let's calculate our radius using Pythagoras Theorem. R squared is equal to x squared plus y squared. R squared is equal to 15 squared plus 8 squared. If you add 15 squared plus 8 squared, you should get 289. And then when I square both sides, I would normally get plus or minus 17 as an answer, but my radius could never be a negative distance. So my radius is now 17. Once you have the three sides of your triangle, you could now write the three primary trig ratios. So the primary trig ratios are sine, cosine, and tangent. So how would we do this? The sine of theta is equal to 7 yellow rabbits. So the sine of theta, sine is y over r, which would be 8 over 15. No, 8 over 17, y over r. 8 over 17. That is your ratio for the sine of theta. What's the cos of theta? Okay, if you memorize that sine is 7 yellow rabbits, cos is x. So cos is, the ratio is x over r. So the cos of theta is equal to, I go to my triangle, x is 15 and r is 17. So my ratio for cosine is 15 over 17. My last trig ratio, primary trig ratio, is tan. And I always tell students, just memorize tan. Tan is always y over x. And you guys, you will do this so many times that you will literally just have this memorized. 7 yellow rabbits, cos is x over r, tan is y over x. So y over x, if I go to my triangle, would be 8 over 15. So tan of theta is equal to 8 over 15. And here are your three primary trig ratios: sine, cosine, and tangent. Okay, what I want you to do now is I'm going to stop this video. I'll show you one quick example though. And I want you to do these questions here. So numbers 1 and 3 to 6. Okay. Now I think what I'll do is let's do 3 together because we're going to have, I'll show you what's going to happen with question number 3. That's really important. Okay. Or was it question 4 I wanted to show you? Just let me have a quick look. Oh, okay, so 3, I don't know why I wanted to show you 3, but let's have a look at this, and then I'll go back to that one point. Okay, so point xy is on the terminal arm of an angle in standard position. So xy, we're always going to put in quadrant 1. So that's point P, and it's x comma y. Draw yourself that point on the terminal arm. Make yourself an acute triangle. And label your triangle. So that's x, this would be y, and that's r. Okay, it says what would be the sine of theta? So theta is right here, and the sine of theta, sine is 7 yellow rabbits, so the sine of theta is y over r. Oh, and that would be it. There's no numbers that they gave me. So the answer for the first one, sine of theta, is y over r. Okay, if sine is y over r, what is cos of theta? Cos is x over r. And the tan of theta is y over x. Those would be your three primary trig ratios. The one thing that I want to point out that I have made a note of down here, let's say you're asked to do a trig ratio of sine of theta, and you write that sine is y over r, 7 yellow rabbits. So let's say y is 3, and you get this to be your radius, 2 root 5. What we always have to do, oh, this will be for question 4. We always have to rationalize the denominator. So we can't have a radical in the denominator. So if you get a ratio and you get a radical in the denominator, what I need you to do is get rid of that radical by rationalizing it. So times both numerator and denominator by root 5. And we would get 3 root 5 over 2 times 5. And that would be 3 root 5 over 10. So again, when you do question 4, you're going to get a radical in the denominator, and you got to get rid of that radical by rationalizing it.